So this talk is by John Constable from the Wellcome Sanger Institute in the UK. The title is iRODS Deployment 7 Years On.
So you may have seen in the notes that I was presenting from the Wellcome Trust Sanger Institute. The Trust have voted to drop the name to just Wellcome Institute. This doesn't mean we're not trustworthy, I think. Anyway, so I've been working with iRODS for about 4 years now. And before that, some of my colleagues set up the iRODS infrastructure at Sanger. And they wrote a paper on what they did. And the link's up here. So you can go and have a look and read through it. And we still get a lot of questions based off of that paper. And a lot of how we work with iRODS in that paper is still relevant today, especially how we get the data into iRODS. We've expanded on it, but it's mostly the same kind of thing. So I'm not going to try and rehash too much, but I recommend you go and have a look through that, and then please come and ask me questions. Also, as you can hopefully see, I'm trying out the Google presentation questions thing, so please feel free to put your questions in there. If I don't get time to answer it at the end of this, then I can hopefully try and answer them a little later on Slack or what have you. So, 7 years, that was a while back. So to go through briefly what we talked about in the paper, the Sanger Institute, for people who don't know, is genomics research. They were part of the Human Genome Project. I think at one point they got to 40% of the contribution, something like that. And since then, they've gone on to deal with large amounts of genome data. As with many people have talked about, the problem is how you handle that data, how you get the data in a format that people can find it, and they can find it later. And so, when people do research there and those people then leave, can you still find the information about it? So we built a number of different systems and a number of clever people. So we thought, I know, we'll write our own repository system. So we did that. Then that didn't quite work out, so we did it again. Then that didn't quite work out, so we did it again. Then we thought, I wonder if anyone else has done this. And then we went to iRODS. So the first iRODS system we built didn't quite work out. The second one we built didn't quite work out. But the third one stayed up. So the third one and on from there is what I'm going to be talking about. By the way, it turns out, if you can see from the slide, that Lego do not make a Monty Python set. I'm really sorry. I was very excited when I found this looking for the slides. So, first of all, we installed iRODS 1.0. The paper that you see in the link earlier was actually written on 2.40. So we've been doing iRODS for a while. And when I say we, I mean the Sanger Institute. I've been working with it since about 3.1 onwards. When we built it, it had a total of 7 servers, some of which are virtual machines. There was 2 zones. We federated 3 zones, if you count the federation. We federated between it. We had a separation between the IES and IRES servers. So we had different servers for storage, different servers to do the metadata. It authenticated against Active Directory, and the point of this was that our end users didn't have to have a separate iRODS account, that they could rock up to their farm account, they could do K in it, and off they go. Their authentication would work. And that has worked very well for us, mostly. The areas where it hasn't has been where we've done the compute against our LSF cluster, and then when, of course, you want to run n number of 100 jobs across that n number of 1,000 compute cores, then you can't have Kerberos working across all of these. And so we tend to use native authentication for that. But we still set it up for Active Directory by default because the majority of our users, 800 odd, are going to be coming in and just doing the simple iGet, iQuest, stuff like that. And as a backend, we used Oracle. We did this because we went to the database team and said, we want something that's supportable, that's robust, that you guys are going to be happy to look after for a while. And they said, we do Oracle. So Oracle it is. I don't think there's that many people these days using Oracle. So this is something of a point of interest for us at the moment. Just as can I get hands up of anyone who's using Oracle as a backend? Okay. For the purposes of recording, no one has put their hand up. Right. Can I get a show of hands? Anybody still using Oracle for anything? No, I'm talking Oracle, the database. That's still a no. Okay. Feeling shiny about our support right now. Okay, good. So we started off, we did the initial local disk thing, and then, of course, we needed to add more storage and more storage. So we started by adding fiber channel SAN. First using NextSAN, then using DDN. We got up to 400 terabytes per server, and the people kept putting data in, kept liking it, so we kept adding more. And we upgraded from 2.4 to 3.3.1. This is in the days when you had to recompile everything yourself and all that kind of thing, so the upgrades took longer than before. Oh, by the way, I need to mention that this is not meant to be a depiction of my colleague Pete Clapham. I have to say this, because he's probably watching the slide later. Hi, Pete. Okay, so as part of all of this, we did a talk a couple of years ago, I think, my colleague John Nicholson did, about moving the data. And because of the way the abstraction works with iRODS, we were able to take half of the data offline, put it in a lorry, drive it down to another data center 100 or 50 miles away, something like that, and plug it all in, bring it all up, and during that time, people were still able to work with iRODS. They weren't able to put stuff in because we were using replication, but it just worked. But at this point, we were running 3.3.1, and 3.3.1 was increasingly getting long in the tooth, and no new security fixes, etc. So with all roads leading to Rome, this is the only Lego I could find with Rome. There was a Lego Colosseum, but it just looked like a lump of Lego bricks. So anyway. And I did talk about the whole process of upgrading. I've since been told that when I did that talk, everyone in the talk was actually already on 4.1. So they're like, that's nice, but we've already done that. But anyway, so it took us about a year to get there. But once we got on 4.1.8, we've been able to do the upgrades pretty seamlessly since then. We're using the packages. Okay, but with all this, we still run into scaling issues. With having individual iRESs, then each one of those could get overwhelmed by the farm. So each iRes has a 10 gig connection. Our IESs have a 10 gig connection. We have hundreds of farm nodes, each with a 10 gig connection. Now, it doesn't take much maths to work out the fact that one could easily saturate the other. We also found, quite entertainingly, that when you plug in a DDN SFA 10K and give it all 16 of its fiber channel ports, make that available to the fiber channel ports on the server, and then tell it to make the path for every single LAN available across all of those fiber channel ports, you get a lot of LANs available. 2,000, I think it was. Ubuntu 12, it turns out, didn't handle that very well, so that made one of those upgrades, OS upgrades, kind of exciting. By exciting, I mean it didn't work. So that was entertaining. So we knew we couldn't just keep adding block storage to the same servers. We also found that the larger the LANs we made, the longer the physics would take. And in some cases, on some versions, the early versions of Linux, we couldn't circuit that kind of scale. So that didn't quite work out either. And of course, as you can go large, but as you go large, you take that one offline for any particular reason, and then the whole of the storage gets available offline as well. So what we switched to instead was more kind of a scale-out option. We used the new servers that were coming along, which were very kind of driven by cloud kind of things, initially from HP, and then more recently from Supermicro. We use these 4U boxes that have a small compute blade, a couple of disks for the OS, and then 60 disks for the array of for the data. And we could basically just rack those. You could get 10 of those in a rack, and you could just scale those out. And because each one of those is an iRes, and the compound resources spread everything out quite well, then what we found was that that actually scaled really nicely. We had an interesting model at the time where what happens was the genomic pipeline would upload a whole load of data, and it would put it on a certain number of resources. And then it would notify the end users that their data have been published. And the users would come along in their hordes from the farm and say, I now want to download that data from the same resources that were then being uploaded to. So this could get quite a lot of I/O load. And we got, I think, loads up to 1,200 on individual servers. But it all kept working. It was pretty resilient, just slower. So we've still got a fair chunk of stuff on Ubuntu 12.04, but we're increasingly moving to Red Hat 7. So as I mentioned, this scales really quite nicely. So I mentioned some of the Lego on these slides is provided by co-workers. One of my co-workers has a desk literally crammed full of assorted different types of Lego. And I'm a big fan of the Iron Man films. So when I found that he had both the Iron Man and the Hulkbuster Iron Man, I couldn't not put a scale up of between the two in there. Unfortunately, I'm not a good photographer, so that's why I have to explain it. So at the moment, it's we're running about 18 to 20 petabytes. I've added some more recently. I forgot to add up the totals of iRODS. And this takes basically one full-time engineer to manage all of this. When we're doing things like upgrades or we're adding new functionality or things like that, sometimes we get colleagues in to help. But generally speaking, it's about one full-time engineer to manage 18 petabytes. As well as the traditional way of getting data out of iRODS and into iRODS, we've also got a read-only NFS export for one of the zones. And this has proven to be quite interesting because what they wanted to be able to do is the scientists are used to accessing their data over NFS, and they're used to writing stuff on the compute farms that says, okay, I want to go out to all the data and not have to stage it all first. So they want to basically, I don't know how people, but a quick show of hands here, people working with genomics? Some, but not everyone. Okay, so just very briefly, the genomics data is stored in BAM or CRAM files, and they have an index, so you can get the bit of you can, in theory, look at the file, get the index, and say the bit of data that I want is here in the file. So you can do a seeking read through the file. You can do that streaming within some tools like HDFget, which understand iRODS, and SAM tools and the like, or you can do that with iGet and just throw away the data you don't want. That's obviously less efficient. It's more efficient if you say, I want this particular bit of data from this X number of thousand files, which is a lot easier to do over NFS, and that's what the scientists are used to doing. And that's what the pipeline for this particular team was already set up to do, their data management system. So this particular group, they were another group that wrote their own data management system. This may sound familiar. System, but they found over time that they didn't really want to keep maintaining this and that they wanted to look at different scaling. So again, they started coming to the iRODS installation that we already had set up. But they wanted to be able to do this NFS export, so this NFS access. So what we came to was by exporting the areas under NFS and making them only available to that particular group's compute farms. And then in doing that, because they had a fairly locked-down security model, we found that's something that could just work. In the current future with GDPR and increasingly high-grained security, this is probably not something that's going to work out, which is why I'm interested to look at the iRODS over NFS that was talked about earlier. But the reason to talk about this is to mention the fact that because we have this as an underlying Unix file system underneath it, there's options for all of this. And one of our ways of designing this was to keep our options open, to keep it as simple as we could make it so that we can still do things with it later rather than cram a lot of complexity in with a particular implementation. So another question we get asked a lot is, how do your users get data into iRODS? And if I'm honest, mostly they don't. I can count on one finger how many scientists have come to me and said they want to put data into iRODS. And it turns out that what they were actually doing is setting up a new pipeline from scratch anyway. So what's really worked for us is getting to the teams that get the data, generate the data in the first place. In this case, the people who analyze the data coming off the sequences, and get them to put that into iRODS. And at the same time they can do that, they can also put the data in, the metadata in at the same time. And that means that then the scientists are then used to going to iRODS to say, I'm going to run my iQuest command to get this particular study, to get this particular run, and they can use the metadata from that. And as a result, it's kind of the de facto way that people expect to get their sequencing data these days. And that's worked very well, I think, for a lot of people. There's room for improvement for all how we can do this, but generally speaking, we've been doing it for 6 years, and people are generally keen for us to continue doing it this way. So in getting here, we had to write a fair amount of our own tools and automation. We've done a fair amount of automation within the systems group. The informatics system group is the part that I'm in. Systems as well is kind of the IT of Sanger, as it were. And we ended up doing a fair amount of configuration management, first CF Engine, then Ansible. Some of our pipeline colleagues, the new pipeline group, ended up writing an entire set of tools called Baton to manage the data ingest and getting data out from iRODS. And the idea there is that it basically takes a JSON file of files that are on the local disk and where it needs to be stored within the iRODS collection, and then any metadata that's to be associated with that. And then it takes care of getting that in, checking the file is there, putting the metadata against it, and all those kinds of things. And this is something that I think has worked very well for scaling that kind of a thing up and having reproducible runs for that, rather than having to write your own wrappers around things. Because at the time we started doing this, the Python iRODS client wasn't even conceived of, I believe. We've ended up coding a number of things in things like Python. We've ended up writing a bit of infrastructure as code, kind of test environment. In a previous talk I gave on doing the upgrade from 3.1 to 4.1, I talked about using the Vagrant test environment where we can spin up an entire, effectively, copy of our production environment with Oracle databases, the whole shebang. We also found we needed to automate some things around recovery. So we had a RAID failure on one of the resource servers, which lost an entire resource worth of data. So thank you very much for that HP and your flaky firmware. And that meant that we had to rebuild that resource, basically. And there's no easy way to say, this resource has gone away, there's a new resource that's in its place, and then we need to backfill that data. So we ended up writing tools that slept around the entirety of the zone, found what should have been there, found where the other copy was, and then rsynced it back to the original. And that took some time to refill back in, but because we were able to mark that resources down with an iRODS, mostly the users just didn't notice, because the resource being down took care of the don't put new files there, don't go and get it from that particular resource, and more importantly, if you're going to overwrite that file, then put it somewhere else and mark that as an orphan file. We'd like some more tools, has to be said, to be able to manage that kind of decommissioning and recommissioning of resources, but this has worked for us. And we've got some of our own fairly basic unit tests. So every time we do a server install or a upgrade, we can run some unit tests that say, do the basic things that our scientists do, I get, large files, things like that, can still continue to work. Monitoring is something that has become increasingly critical. We've got 60-odd servers, I think, something like that. As I mentioned, 18 petabytes. It's spread across a large number of infrastructure, 5, 6 different zones, multiple different IAS, multiple different iRes. So to be able to see what's going on with all of this requires a fair amount of different automation. And we've got a number of different tools scratching a number of different spots for this. And as always, you can always compress this down, but we've not used the tools you can set up here for this kind of thing. If you've got any questions on how we do any of this, I'd be happy to give a demo of what we do and how we do it and what the dashboards look like and that kind of a thing. But it's not really something I can talk through right now. It's probably a whole talk in itself. So, as I mentioned, 129 servers now, so you can't keep count. We have a dev zone which mirrors what we have in production in terms of it has the same number and name of resources, but it doesn't have the same size because, funnily enough, we can't afford another 18 petabytes just to do testing with. So overall, what have we learned from this is monitoring, logging, instrumentation, observability has been really key for when things go wrong, when people commit 100 or 200, 300 jobs on the cluster to try and download stuff, who's doing it, why they're doing it, that kind of thing has been really critical for running it at the kind of scale that we have. We could also, within Sanger, we could do with an infrastructure as code approach to be able to say to people, if you want an exact copy of how we've got our set up, Oracle databases, federation, all these kinds of things, then you can spin this up so you can test your own infrastructure against it before you do that. And it's something that we can now do as we have our own OpenStack cloud. The other thing we found is that at the scale that we're at, no matter the, the amount of testing that's gone into it that we do, that Rentsy do, and there's a lot of testing that goes in from our side for this, we still end up finding edge cases and edge case problems. And they're always the tricky ones, right? It's never the simple ones that you find. So what we can find with this is that when we find issues and things, it can take some time to get resolution for them. And again, this isn't because we're not getting support, we're getting a lot of support, we're getting very helpful support, but these things are fairly, distributed systems are hard, right? Thank you to my colleague, Dr. Clapham, who was one of the initial authors of the paper and now my boss, and setting all this infrastructure up in the first place. And thank you to Dr. James Smith, of which, half of which the photos of the Lego come from him. So, thank you all, and any questions?
I'll bring the mic to you.
Thank you. So I'm interested in the read-only NFS export that you mentioned. How are you handling the authorization? Are you using the iRODS authorization or just export data that the user has access to?
Yeah, so it's a good question, and we talked a bit around that. We're fortunate in the fact that that particular group have all of their members are in one Unix group. And they were happy for us to say members of this group can read it. And so we only export this NFS to the farm nodes that belong to that area. And then we basically set up Unix permissions with sticky permissions on the top-level directories that force it to group UID for that. So any files that get created get set with that particular permission set. And we can, it was much harder in 3.3.1, but in 4.1 you can now set what the user in the group is for the service user at creation, and then that becomes easier for as the iRODS writes out files, it writes it with the right group, and then everything can go in and see that. As I mentioned, it's going to be harder in the future when we might need to say, okay, I know this is all cancer data, but in this particular case, this is one particular group of cancer data that only these particular people can see, and we can't handle that at the moment, and the group know that, and we're going to have to be thinking about that in the future. So it's entirely likely we may well end up turning that feature off at the moment until we've got something that works with that. We shall see. A number of different options in play on that one. Did that help? Anything else?
Any other questions? All right. Thank you.
Thank you all.